Okay. Hi, everyone. So we're going to talk about software that acts, and there is plenty to go through. So I'm going to jump straight in. Let me tell you a bit about myself. I'm a technologist, founder. Currently, I'm the Chief Product and Technology Officer at a company called Open Dialogue. We've been going for about 3.5, 4 years now. Open Dialogue is a conversational AI platform, and we work mostly with insurance companies and healthcare organizations, kind of regulated industries. I have a PhD in computer science, and I put the title of my PhD there just because it's relevant, right? I spent a lot of time thinking about agent-based systems and what is agency and what is autonomy and so on, and that was what my PhD was all about. I wrote a book called Agent-Based Software Development almost, it's a bit scary, but it's almost 20 years ago now. And more recently, like a few years ago, I wrote a book called The AI-Powered Workplace. The one thing I do want to sell to everyone is my Substack. I'm excited. I have a Substack. It's called Agents Decoded. It's free, obviously. You can go there and sign up, and I write about all things agents. Okay, what is our objective? So my objective is over the next 20 minutes or so to give you some tools and some ways of thinking about AI and agents that will allow you to reason about these things with clarity and calmness, so that you can choose what strategy you want to deploy and what technologies you actually want to use. To achieve that, we're going to talk about what is AI, what are agents, how we can think of designing with agents, and how we can think of building with agents. So let's start with AI, and my favorite quote about AI, and it's from the Iliad, and it's, I guess, about coming up to 3,000 years old. So it said, Thetis found Hephaestus hard at work and sweating as he bustled about at the bellows in his forge. He was making a set of 20 tripods to stand around the walls of his well-built hall. He had fitted golden wheels to all their feet so that they could run off to a meeting of the gods and return home again, all self-propelled, an amazing sight. So what I find amazing about this quote is, already 3,000 years ago, and probably much more than that, we have been thinking and we have been exploring how can we build machines that do the sort of things that we do, and how can we give those machines the jobs that we are supposed to do. And then the other nugget here is that the first job is meetings. 3,000 years ago, we're still trying to get out of meetings, even though it was supposedly, I guess, an Olympus with the gods, but Hephaestus, as a good engineer, was still trying to get out of it. So what is AI? AI is exactly that process of attempting to understand intelligence. It is a field of science. It looks at intelligence, it creates models of intelligence, theories of intelligence, and then we go and build machines that are going to help us validate that hypothesis, right? So we build the machines and we have them solve problems, and if they manage to solve problems, we think we may have hit on a model of intelligence that is useful. It can solve some problems. The process of developing these models, these tools, these techniques, that is the field of science of AI. So when someone says, I want AI, or they say, my phone is AI enabled, I'm always, what I hear is something like this. I've got math, I've got physics. Those are fields of science, right? You never really want AI in the same way you don't say, oh, I really want to have more math in my software. I'd really appreciate some more physics. What you want is to solve a problem. And if that problem has to do with something that looks like intelligence, you want to look at the field of science of AI and say, okay, what tools and techniques can we use? So when we say we want AI, what we actually mean is that we want to delegate decision-making to machines, right? We want software that we can ask questions to and it will provide answers. We want to automate processes, prediction, whatever it is. There is something that we are currently doing and we want to delegate the job to a machine. And the field of AI is the space within which we can go and look and say, okay, what tools, what techniques, what methods are there that will enable me to delegate this decision-making to a machine? So there's no AI. AI is an entire field with lots of different ways that help us delegate work to machines. I'll give you one more definition and then we'll move on to agents. This comes from an Italian philosopher called Luciano Floridi. And Floridi says AI is the decoupling the ability to solve a problem or complete a task successfully from any need to be intelligent to do so. Now think of that for a bit, right? You decoupled the need to do this thing from the need to be intelligent in order to do it. That process of decoupling is where AI is. Okay, so if that is AI, AI is a field of science and it studies intelligence and it gives us this interesting tools and techniques and models. What are agents? Well, agents are when AI has a goal, when AI is trying to do something, right? Or a software that uses AI techniques is trying to do something. It's about the action, it's about moving away from just the process to what is the goal of the process. Ultimately, agents are an abstraction. They're the thing that we came up with to describe systems that use AI tools and techniques in order to achieve something. And when we're thinking of agents or the agentic web or whatever this thing is, the question we should be asking ourselves, is this abstraction useful? We can describe this thing in any number of different ways, right? We have lots of different ways of describing systems. If we introduce this concept of an agent, does it help us reduce cognitive load? Does it enable our teams to communicate more efficiently about the system? Does it enable us to describe patterns of how we would use these agents so that we can apply it across different domains? That's what's going to define the value of this abstraction of an agent. And just to give this some more depth, we use abstractions all the time. Documents. I hope you would agree with me, but it'd be interesting to hear alternative ideas. Documents are an abstraction, right? We have this set of words, and they're all in relationship to a specific topic, and there's some metadata associated with these words, like the date they were written and who wrote them, and so on and so forth. And we decided to call all these things together a document. And we can talk about the interface to a document. We can talk about document composition. We can talk about document communication, right? Cross-references, links, and so on. And we can start talking about reuse and patterns because we are talking about document templates. It's a similar thing with agents, right? So we have this software which we're delegating decision-making to. And what we're doing is essentially hiding the reasoning and talking about the actions that it can take, its capabilities, and the goals that it has, right? And it enables us to talk about composition because we say, well, we have this thing over here that has this goal and this other thing that has this goal, and they can communicate through message passing and so on, and they have different architectures. And if you think of the evolution of software engineering in general, it's sort of natural that we ended up with this concept of agents, right? The very start, you had procedural programming, where you are providing every single instruction. Do this, do that, set this to that value, and so on and so forth. Then you take that and you say, actually, this set of procedures, I can bunch them up together, and I'll call that a function. So I don't have to refer to every single step. I can just talk about this function that takes an input, provides an output. And then we said, well, actually, the world that we are modeling is more complicated than that, and we want to be able to talk in terms of objects. So let's say I have a person and an organization, and I have something called a transaction and so on, and I'm hiding their state and how they behave, and I'm exposing the different methods that I can call on these objects. And you take that a bit further and you say, actually, my software can now take some decisions for itself. So how do I describe the software? Well, I can start talking about what goals does it have, what capabilities does it have, maybe what knowledge it has access to, and so on. So agents are an abstraction that help us describe AI systems that perform actions. And the value of this abstraction is going to be measured in its ability to enable us to describe complex systems more efficiently. So let's try and do some of that describing of systems, right? How do we design with agents? I think the first sort of most interesting thing is that at the design stage, or sort of an AI strategy stage, the abstraction of agents is quite powerful because it allows us to focus on the what, so the end result, if you want, without having to immediately need to think about how are we going to get there. One of the traps that a lot of teams approaching AI fall into is to start worrying about the specific tools. What LLM model am I going to use? What LLM framework or other framework, and so on. But you haven't even talked about what it is that you're trying to build, right? You have to focus on the what you're trying to achieve, and then decide how you're actually going to do that. So what is the what of an agent? And I'm synthesizing quite a bit here, but I think the core ideas are this, right? So an agent is an entity able to pursue a goal. And we have to define what this thing is. What is a goal? Because we actually have to eventually build a system. So we have to try and be as precise as possible. So a goal is a desirable state of affairs that can be described in terms of attributes of the environment that we are in. Right? So imagine a world in a certain state. The agent interacts with this world, changes it to bring it to a new state. In order to achieve its goal, we have to be able to describe that change so that we know that we've actually achieved our goal. And an agent has capabilities that can either affect that change or can sense the environment and understand what's going on. Now, if you have this set of abstractions, you can take something as simple as a thermostat and describe it in terms of agent-based ideas, right? So you can say, well, my agent is a thermostat, and its goal is to keep temperature at 20 degrees Celsius. And it has capabilities. It can sense the room temperature, and it can switch my air conditioning unit on or off, right? Now, you could argue this is very simple agent, right? It senses the temperature. If the temperature is over 20 degrees, switch the air conditioning on. If the temperature is under 20 degrees, maybe switch the air conditioning off, right? It's not about how complicated something is. It's about having clarity of how you use these concepts in order to describe it. And we can describe anything in terms of agent-based ideas. Now, typically, you wouldn't want to reach out to agent-based software engineering to describe thermostats. But if you're describing something a bit more complex that actually uses a variety of AI techniques and so on, that's where you start getting some value out of using this abstraction, right? So to give you a more sophisticated example, imagine you have a documentation journey agent. I tried to think of problems within the documentation space, which is not my space, right? So imagine you have a documentation journey agent that can generate custom documentation journeys. You can say the goal of this agent is achieved when a new documentation journey is created and the user has accepted it. And the agent has certain capabilities, such as reading existing documentation, reasoning about the user profile, generating a synthesis of information, presenting that information in a variety of ways. We're not saying how these things are going to be achieved, but we're saying this is what we would like to have, right? We're at the design stage here. And you take that idea further, and you can start talking about playbooks built around agents, right? So you can start talking about different agent types. Maybe I split a bigger problem into, well, I'll have an agent that just researches, right? It just gathers information. I'll have an agent that just drafts topics. I'll have an agent that monitors existing information and tells me when it's been updated. I can talk about the environment within which my agents are going to live and the things that they have access to, right? Like the documentation platform, the code base, and so on. I can talk about my agent's life cycle. How do I onboard them on this environment? How do I retrain them if something changes? How do I monitor them? And then now you're starting to develop a more sophisticated playbook, a strategy playbook around what sort of things you want to build, how they are going to communicate with your existing environment. You're starting to put in place some policies, some governance, and so on. You're still not worrying about the how they're actually going to be built. But eventually, you will need to build them. So let's talk a bit about the how. And what I want to do here is also talk a bit about how we ended up with agentic. I think it's useful to just clarify, how we got here, what was there before, what of concepts were there before, maybe some of the things that are currently not talked enough about right now, and that will get us to an overall better, clearer place. So how did we get to agentic? Right? In the beginning, we had this model, right? Say the beginning is depends on when you started working with LLMs. Let's say when ChatGPT was launched, this was the model of execution, right? So you'd send a request, it would go hit the large language model, would generate some instructions, and the expectation is the user reads this information and then goes and does something with it. So the user executes. But we are impatient and lazy creatures. So we immediately said, well, hold on. If you're generating the instructions and then I have to go do them, could you please just go do the thing yourself, right? So we ended up in this place where you send a request, goes to the LLM. We've connected this LLM with what most people call tools, which are essentially different capabilities that what is starting to look like an agent has, right? So the LLM could say, oh, the user is asking to do some calculation. I actually have a tool that allows me to write some Python. I'm going to go write some code, execute it, and give them the result of the thing, right? So we reason, we use the tools to execute, and then provide results. And the job of the user is to verify. And if you squint and you look at this system and you have some idea of agent-based software engineering and so on, you sort of go, oh, this is kind of agentic. And here's the term agentic, right? So it's a step towards an agent-based world and agent-based software engineering. But I think what's interesting is to take those extra steps and talk a bit about some of the concepts that are missing here. So let's dive into it. I think that the first thing that's really important to pull out is what happens before I use a tool. And before I use a tool, I come up with a plan. Now, there's always planning happening. Someone needs to decide what's going to happen. The question is, who controls this planning? In most applications that I've seen out there, essentially the LLM controls the planning, right? The LLM has been trained to solve a variety of problems, and it comes up with a series of steps. In best of cases, sometimes it doesn't even really think of it as a series of steps. It just does something and then it does something else. If you're building applications, especially in a business context with set workflows where governance is important, think about who controls that planning. And maybe some of it is done in the LLM, but maybe you can guide the LLM to a certain extent to say, here's how I want you to think of the solution to the problem. Here's how I want you to think of how to use tools in order to provide some results, right? So planning is an important concept in agency that we should always consider. The next thing is to actually think a bit more deeply about these tools, right? And say, well, you have things that change the environment and things that can tell me what has happened in the environment. And you can think a bit about, if I perform a change, can I actually sense that change? Can I actually tell that it has happened? You would be surprised in how many cases the application cannot actually know that the thing that it was supposed to do has actually happened, right? But if you can do that sensing bit more clearly, then that's going to help with your planning and so on. The other really big thing that is missing is an explicit representation of a goal. A bit like planning, goals always exist, right? The user has a request that is partly a goal. That's going to go to the LLM. The LLM is going to come up with a different goal. The question is, has that been made explicit? Does your application as a whole have a space where it can say, is this a goal that I actually want to pursue or not? A very same thing to do with applications is give them the ability to say, no, that is not something that I'm designed to do. It's just not something that I want to do in the context of my purpose and so on. And so having an explicit representation of goals, it can be extremely valuable. And remember, goals always exist, a bit like plans. It's just a question of, do you actually know what the goal is or not? Can you look into your application and pinpoint, oh, that's the goal that it was trying to achieve or not? Now, within the context of goals, something important to think about is this concept of self-direction, right? So you have this application, we're delegating decision-making to it. It generates a goal. To what extent can it decide how to achieve the goal? If the only thing it has is, it's a thermostat, and the only thing it can do is switch on and off an air conditioning unit, it has very little self-direction. There's very little that it can actually do. If it's a more sophisticated agent, it can have a goal, have all sorts of different ways and apply different plans in order to achieve this goal. So think about your system and think about the level, the degree of self-direction that your system needs and you're willing to give it. Right? And obviously self-direction is on a continuum. It's self-directed or it's not. It can be very little or very much and so on. Now, once you have goals, you can also start saying, actually, the request from the user is not necessarily required. I can just keep working against my goals without taking a request in. And the other thing to consider is, how are your goals generated? Right. So we talked about self-direction as an agent's ability to decide how to achieve a goal, but how did that goal get there in the first place? Right? It could be that it came through a request from the user, and it's something that's within the remit of that agent. It could be that it's set, kind of hard-coded upfront, like anything that does updating or monitoring of things. Or it could be that you have a higher order concept, which in this case we're going to call motivations. You could call it anything. And the minute you have motivations, that's when I start thinking about autonomous agents, right? So these are agents that can generate their own goals. The easiest way to think of motivations is think of us as humans, right? So our goals are specific things that we want to change in the environment. Our motivations are the things that drive us to generate those goals. So I'm motivated to stay alive, therefore I'm going to generate a goal to go eat. I'm motivated to be recognized in my professional environment, therefore I'm going to go generate a goal to go talk at a conference and so on and so forth, right? Once we're able to generate our own goals, we can start talking about motivations and autonomous agents. Okay, so that starts giving you a better sense of what an agent architecture looks like. You can you reason, you have actuators that change the world, you have sensors. There is a plan that is going to tell you how to use your actuators and sensors to affect change. That change is in service of a goal, which is a describable state of your environment. And that goal can either be ascribed directly, so you as an agent didn't really choose it, or that goal can be generated because you have a higher order reasoning around motivations or preferences and so on. Just in the last 2 minutes, just a few things to keep in mind, which are your standard disclaimers, especially in LLMs. Beware of the reality gap. All the limitations that LLMs have, which remain very real, feed into agent action, right? And when we build software that acts, essentially what we're doing is we're taking those, especially those hallucinations, and turning them into reality. There's lots of ways to solve these problems. You just need to be very aware of them. Think about what it means to build safe agents, where you prevent accidents, misuse, and so on. Think about trustworthiness and give yourself a definition of trustworthiness that you're happy with, such as I can provide evidence of why I did what I did. And then think about compliance, especially if you're in a regulated environment. Okay, I think I'm coming up to time. Don't know if I mentioned my Substack. I have a Substack. It's called agentsdecoded.com. Fantastic. Thank you very, very much.